In the last few videos, we talked about the wave nature of light. Prior to the early 1900s, most of the properties of light could be explained with its wave nature. Then, as the number of discoveries brought classical view into question, classical view is the explanation of properties of light using wave nature. So after new discoveries started coming up, that view was questioned, and one of the most important one was the photoelectric effect. So what is photoelectric effect? Very briefly, if light shines on a metal surface, electrons are emitted out of it. So one thing is that according to classical theory, if light shines on a metal surface and electrons are emitted, the lower intensity of light will not make the electrons get emitted faster. If the intensity of light is higher, then electrons get emitted faster, but if the intensity is low, then there is a lag time between the emission of electrons and the shining of light. But they found that even though the intensity of light is low, electrons get emitted out of the metal surface, and this could not be explained by the classical mechanics or classical theory. Einstein explained that the light energy that's delivered is not in the form of wave, but it could be in the form of packets called quanta of photons. And the energy of the photon of light is directly proportional to the frequency. So inversely proportional to the wavelength, because it's directly proportional to the frequency. I don't know if you remember, but we have seen in the previous video that frequency is inversely proportional to wavelength. So the energy of the photon is directly proportional to the frequency, so thus it's inversely proportional to the wavelength, and the proportionality constant is known as the Planck's constant with a value of 6.626 times 10 raised to negative 34. So energy is directly proportional to frequency, energy is inversely proportional to wavelength, and using these explanations, photoelectric effect could be easily explained. So light has wave nature as well as particle nature, and this is known as dual nature of light. And the similarity is that electrons also have dual nature. They have a particle nature and a wave nature. So some properties of electrons could be explained if we take wave nature into consideration, and some properties of electrons could be explained if we take particle nature into consideration.